Frontal lids 6 in number, bipolar lids, standardized, also called standardized lids, limp lids. These are 3 in number, augmented 3 in number. Frontal plane, these 6 lids are present in frontal plane, that is a vertical plane in the body. Now bipolar lids are created. These are 3 in number, 1, 2 and 3. They are placed in various vectors in various axes, something like this. This is 2, this is 3 and this is 1. To create this kind of vector along the heart, we need to place positive and negative electrodes on the body, something like this. This is left leg, this is left arm, this is right arm. So vector 1 is on the horizontal axis, so it will be VL minus VR, left arm minus right arm. Vector 2 will be VF minus VR. Vector 3 will be VF minus VL. When we place these vectors, they form an equilateral triangle called the Enthoven's triangle. These resemble the pathway of current flow during depolarization. Moreover, on analysis, it can be shown that the sum of potential in lead 1 and 2 is equals to lead 1 and 3 is equal to that of lead 2. That is, lead 2 is equals to sum of potential of 1 and 3. Lead 2 is equals to VF minus VR, which is equals to VL minus VR, that is lead 1 plus VF minus VL, which gives you VF minus VR equals VF minus VR. Therefore, this can be concluded that lead 2 represents the cardiac axis of depolarization, and it is the sum of the vectors of lead 1 and 3. Now in augmented, how do we create augmented limp leads? There are 2 electrodes, one exploding electrodes and another is zero potential electrode or indifferent electrode is used. Okay, indifferent electrode is placed at a resistance of 5000 ohm to make it zero, and the sum of all the augmented leads, that is VL plus VR and VF, is equals to 0. Augmented lymph node is created by putting a standard lymph node at positive terminal and making the other 2 lymph leads 0. These are designated as AVL, AVR and AVF. AVL is made by making the left arm positive and the other limbs negative, left arm positive. This is by right arm positive, other 2 zeros, making other 2 lymph leads zeros, and AVF is produced by making left leg positive and other 2 negative. Here we can see that AVR is equals to VR minus other 2 is 0, making them 0, that is VL plus VF by 2, that is 2AVR equals 2VR minus VL plus VF. Since we know that VR plus VL plus VF is equals to 0, Enthoven law, from Enthoven's law, therefore VR is equals to minus of VL plus VF. So we'll substitute over here, so we'll get this one, we'll substitute this in the first equation over here, then we'll get VR is equals to VR plus VR by 2, which is equals to AVR is equals to 3 by 2 VR. So augmented lymph nodes increases the potential by 3 by 2. 3 by 2 times of the bipolar basic lids. Next is horizontal lymph lids. These are basically in anterior plane, horizontal plane. So it would be like this, like a CT cross section of the body we'll have to take. This is the vertebra over here, this is the heart, and the arrangement is V1, V2, V3, V4, V5 and V6. Okay, to break the precordial leads, each chest electrode is made positive in turn using the active electrode. They are positive in turn means one's positive, other is negatives. V1, V2 are in fourth intercostal space. This is at the right of sternum, this is at the left of sternum. Fourth intercostal space, fourth IC. V4, V5, V6 are in fifth intercostal space. V4 is mid clavicular, next is mid axillary, and final is anterior axillary and mid axillary. V3 is present midway between V2 and V4, midway. Okay, so these are the horizontal leads. Then we saw the vertical leads. So total 12 leads are there, 6 horizontal, 6 vertical. Now we'll see the in ECG reaction to all these leads. Now each lead has its own orientation, okay, own vector in various angles of heart. It will record I already explained that when it will record positive deflection, when it's along the vector negative deflection, when it's opposite the vector of the heart, and biphasic when the lead vector is perpendicular to that of vector of the heart. Okay, so vertical leads are placed something like this. This was, we saw vector 1, vector 2, vector 3. We had here AVF, AVR and AVL. This is a 360 degree of a circle, so we can extend it here. This is plus 90, this is minus 90, minus 180, and this is 0. So lead 1 is at 0 degree, lead 2 is at 60 degree, lead 3 is at 120 degree, lead AVR is at minus 150 degree, AVFL is at minus 30 degree, and AVF is at plus 90 degree. Now you can see these 3 leads are at the inferior surface of the heart. These are called inferior leads, and these basically represent the vector of depolarization of heart directed in the direction of the diaphragm. That is that portion of the heart that rests in the diaphragm, inferior surface of the heart. Inferior leads, diaphragmatic surface. Lid AVL and 1 is left lateral, also called left lateral lids. Okay, and AVR is directed in the cavity of the heart, if you see. Therefore it's also called cavity lid. In case of horizontal lids, we have right ventricle lies medial and anteriorly, and left ventricle lies posteriorly and laterally. So therefore median and anterior is the best represented by V1 and V2, and that left ventricle is represented by V5, V6, and the interventricular septum is represented by 3 and 4, V3 and V4. Also V1 to 4 is called anterior lids, and V5, V6 is called left lateral lids. So to summarize, Left lateral leads we have 1 AVL 5 and 6. Left lateral leads. Anterior leads we have V1 to 4. Inferior leads we have 2, 3 and AVF. Cavity lids we have only one, that is AVR. We will see the orientation of P wave on various lids. These are the frontal lids and these are the horizontal lids. Okay, the average SA depolarization goes along this direction, this gray arrow, that is right to left. Therefore you can see that left lateral lids and the inferior lids will record a positive deflection. The AVR sees the electric current as moving away, so it records negative deflection, and lead V1 lying over the right heart is oriented perpendicular to the direction of